Hello and welcome. My name is Ashish Ahuja. I'm an applications engineer with Texas Instruments. In this video, we will discuss some guidelines for using Ethernet controller on the brand new Tiva C-Series TM4C129X family of ARM Cortex M4 microcontrollers for applications that connect, communicate, and control. To be specific, we will go over clocking requirements and recommendations for different configuration of Ethernet controller module. We will review a schematic that you can use as a reference for your applications involving Ethernet using TM4C129X devices. We will also discuss some key points to be kept in mind while making selection for external components such as termination ion bias resistors, decoupling capacitors, isolation transformer, etc. Followed by this discussion, I will also share some signal routing and board layout guidelines with you so that you can optimize your application for the highest performance. So, let's get started. The TM4C129X products have been architected to keep in mind the requirements of a number of cost-conscious home and industrial automations in mind. To reduce the overall BOM cost and required footprint size, we have designed the Ethernet controller so it can be clocked from the main oscillator. Only one 25 MHz clock source is required. It could either be an external crystal or a single-ended clock source to generate the clock for the core, memory subsystem, and the Ethernet controller. This is a benefit as compared to the legacy products which required two separate crystals, one for the oscillator and another for the Ethernet controller. While routing the traces for the crystals and laying out the board, for accurate oscillator operation, you should minimize the loop area for oscillator signal and reduce the overall trace length. Do factor in the stray capacitance due to the trace lengths, PCB construction, and the microcontroller pins while selecting the external crystal and sizing capacitors C1 and C2. Depending on the package option, some TM4C129X devices have a ground X2 signal. Please take a look at the schematic on the screen on how this should be connected. New TM4C129X devices with integrated Ethernet controller are available in different configurations so that you can pick and choose the device that is best fit for your application and cost point. We have devices with integrated PHY and also with MAC only option, which provides you with the flexibility to pick and choose the external PHY as needed. Integrated MAC only devices are available with MII or reduced MII interface. In either case, the system clock should be at least 20 MHz if you are using the MAC, and an external 25 MHz clock source is required if you are using the integrated PHY. For the rest of this video, we will focus our discussion on TM4C129X devices with integrated MAC and PHY. For such devices, a small number of passive external components are required to be connected to properly decouple the noise and terminate the differential pair. Let us take a look at each of those and discuss how you can size them and lay out your board to achieve most optimal performance and improved EMC/EMI immunity. Devices with integrated PHY require 4 termination resistors, and these are indexed as R37, R40, R41, and R42 in the reference schematic. They are required to pull up the receive and transmit differential pair. For most cases, 50 ohm resistor with 1% tolerance are good enough. A separate resistor R bias is also required to be connected to the R bias pin of the Ethernet controller to set the bias voltage for the Ethernet controller. It must be 4.87 kilo ohm with 1% tolerance. R bias resistor should be placed as close to the R bias pin as possible with a short trace to the ground which is not shared with other microcontroller pin. In order to provide electrical isolation between the microcontroller and Ethernet network, a 1-to-1 transformer is also required. For improved EMI performance, use magnetics with integrated common mode choke. And do not forget to refer to the microcontroller datasheet to find the list of part numbers for approved magnetic options. Do review the reference schematics to see how to connect the center tap of the transformer, decoupling capacitors, and provide Bob Smith termination. Now, let us spend a moment and talk about the RJ45 connector. For better EMC/EMI performance, you can use a shielded RJ45 connector and connect shield to the chassis ground. Common mode termination to the unused receive and transmit pairs can also be provided using Bob Smith termination method. Generally, you will use a 75 ohm resistor for that. Most industrial and building automation applications expose the microcontroller to ESD events. It is recommended to provide ESD protection by means of transient voltage suppressant diodes on the differential lines between the transformer and RJ45 connector. That's pretty much what you need to take care of. TM4C129X devices have Ethernet activity LEDs, which can be programmed to indicate the link status. They are multiplexed with GPIOs and can be programmed to operate in common anode or common cathode configuration. Now that the right external components are selected, it's time to place them on the board. Keep in mind that time and effort invested early in designing a good PCB upfront will not only improve the overall performance of the system, but also save you time and money later on. Let us walk through some examples of good and not so good layouts. Refer to the schematic on the screen. Termination resistors and decoupling capacitors for the Ethernet signals should be connected as close to the Ethernet pins of the MCU as possible. Also, you should avoid stubs where possible. Keep stubs as short as possible and maintain the symmetry. Traces for differential signals should run parallel to each other and be as short as possible and match in length. While maintaining parallelism is not possible, try to minimize the length of traces that are not parallel to each other. Do not route the differential signals through a split plane or between different conductive layers. And also try to minimize the crossover with other signals. Try to just avoid it if possible. Avoid the routing differential signals through vias. Routing of receive and transmit differential pair is critical in systems where immunity to noise and robustness in general is required. The receive and transmit pair should be separated from each other by at least 1.27 millimeters, and they should be routed to achieve the overall 100 ohm differential impedance and 50 ohm single-ended impedance. The isolation transformer should be placed within 2.54 centimeters of the RJ45 connector. The filtering cap should be placed as close to the transformer as possible. Special attention must be paid to how the ground and power planes are routed. Do not extend the power plane under the Ethernet signals unless there is a solid ground plane between the differential Ethernet signals and the power plane. The ground plane should not discontinue under or near the differential signals between the microcontroller and the transformer. Some of the suggestions that we have discussed just yet are shown in the example layout implemented on the screen. Pay attention to the fact that the ground plane is not extended under the signals from the isolation transformer to the RJ45 connector. That's a lot of information to keep in mind. To make it easier for you, Tiva C-Series system design experts have authored an application note that provides in-depth system design guidelines for systems involving TM4C129X devices. The application note is available online on www.ti.com/tiva-c. Go to the Technical Documents tab to download your copy right now. So today in this video, we learned about the clocking requirements and recommendations for different configurations of Ethernet controller module. We reviewed the reference schematic section by section and discussed guidelines for external component selection, optimal signal and board layout so that you can achieve the highest performance while using TM4C129X microcontrollers in your end application. I encourage you to review the product data sheet and visit the link shown on the next screen should you need more information and support. Thanks for watching and stay tuned for more exciting and innovative products.